We are continuing with quadratic functions, actually with quadratics, and in previous two sessions we went through concepts of factorizing quadratic trinomial. Then we learned concepts of solving quadratic equations, and now we should investigate some concepts in sketching quadratic graphs. When we are saying quadratic graphs or quadratic function, we have to keep in mind the basic difference between quadratic equation or equation generally and function. While equation has only one variable, let's say x anyway, for functions we have two variables. So when we are talking about quadratics, we said quadratic equation is in the form ax squared plus bx plus c equal 0. But on the other hand, if we are talking about quadratic function, then we have to have another variable that is dependent variable, usually marked by y, and when we're writing like this, y equal ax squared plus bx plus c, then we are talking about quadratic function. The graph of quadratic function is so-called parabola, and all of you know what parabola is. So that is one curve, symmetrical actually curve. It has a line of symmetry right through a turning point. For investigating a graph of quadratic function, we have to apply one method that will be actually your major interest in graphing through year 11 and year 12. That is graphing by transformations of graphs. So what it means? That means basically that we have to memorize, we have to understand basic graph for, in this case we are talking about a quadratic function. So the basic graph of quadratic function, the basic parabola, and then to know how to apply transformations to that basic graph to obtain a required graph. So when we are saying transformations, just to go a little bit backwards, probably a year or two, I don't know, in different schools in different years, people are studying transformations. But when we are talking about transformations, we are talking about horizontal and vertical translation. We are talking about dilation. We are talking about a reflection in the x-axis and reflection in the y-axis. Just before we start sketching quadratic graph, just to refresh a little bit your memory about transformations of some line or graphs. Let's say if point A with coordinates, I don't know, just roughly, let's say 3 and 2, is a part of some graph of some line, let's say, of our parabola. Then, if we have horizontal translation, let's say for 2 units to the right, then we have to add to x coordinate another 2 units to obtain new point. So in that case, point will be probably somewhere here with coordinates 3, that is x coordinate, but we are adding 2, and of course y coordinate stays the same, because we are translating this point I will mark it with one dash here. We are translating that point to the right, or if you are translating to the left, then of course will be 3 minus 2, so will be point probably somewhere here. On the other hand, vertical translation is actually when this point going up or down, and if you are translating that point, let's say for 4 units, then we have 2 and another 2, so it will be probably somewhere here, and again that coordinates in this case for x will be the same, but we will add 4 to y coordinate, and we will go up with that graph. A reflection in the x-axis simply that point comes down, because x-axis then will be symmetry for those 2 points, and we are saying we have a reflection in the x-axis. Similar reflection in the y-axis, then point will go on the other side of y-axis, and we have y-axis as a symmetry between for those 2 points. The dilation factor is a bit more complicated to understand, but because there are 2 different dilations, dilation in the x-axis and dilation in the y-axis, but for parabola we will talk only about dilation from x-axis or in direction of y-axis. And let's say if this point dilated for, let's say, 4 units from x-axis, then in that case we are multiplying y coordinate by 2. So will be 2 times 4 is 8, and that point will be somewhere here, and I will just write coordinates of that point. For x of course stays the same, but for y will be 2 multiply 4. So while a vertical translation we are adding a coordinate, for dilation we are multiplying actually coordinate by the factor of dilation. This is just a little bit to refresh your memory, and this will be used for transformations of any graphs that later on you will study. Anyway, now we will go back to our quadratic function, and to see how to sketch a graph of quadratic function applying actually these transformations of graphs. So the basic form, this is standard form, of parabola, but basic form of parabola is y equal x squared. So why we are calling this basic form? It is the simplest form that telling us that we have one quadratic function, simply x to the power 2, because b is 0, c is 0, a is 1, and really this equation can't be simpler than that to still to be quadratic function. So the graph of this quadratic function of this basic form is, you know, that graph in school, you probably in year 9 usually start sketching this graph by giving value for x and calculating value of y and connecting those points. But anyway, we have graph like this, and that graph we are calling a parabola. It is very critical this point here, where parabola changes behavior from decreasing graph and all the time is coming down, decreasing, 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 and from that point start increasing. And that point is so-called turning point. So this is a basic graph, the simplest graph. But what to do with that graph if we have, let's say, equation of parabola, I don't know, x squared minus 3x plus 1. So what would be the graph of this parabola? Obviously, should be different than this one, but to obtain that graph, we have to still use this graph. So what else should we know to sketch this graph? Of course, we have to know how all those coefficients changing actually this graph, and how actually they are reflecting, translating, dilating, or things like that, what we spoke at the beginning. To be able to see that, definitely we need some different form that will tell us exactly everything, how to transform this graph to that graph. And that form is so-called turning point form. So I will copy a standard form again. Here y equal ax squared plus bx plus c. But turning point form is, of course, can be plus or minus a, x plus or minus can be some number h to the power 2 minus or plus k. And this form we are calling turning point form. So, it is obvious that this form we can get from standard form if we complete the square in standard form. So, by completing square here, we will get equation like this. Of course, in case if we have equation like that, but we need standard form, then we are going backwards. Instead to factorize, now we have to expand. So when we expand this, we will get that form. Why this form is important for us to sketch this graph? It is important because here in this form all those numbers with plus or minus are telling us exactly about transformations of that graph to this graph here. So what we have to memorize here, what we have to really keep in our mind when we analyzing a graph, I will mark with numbers, and this here plus or minus telling us about reflection. We discuss reflection. In the x-axis, telling us about reflection, and I will just write reflection. So if we have minus, then our graph is reflected. But if it's plus, then our graph is like this. So what it means, reflected graph? I will sketch small graph here. Let's say this was our basic parabola, but if we have minus in front of this expression, then that parabola will be reflected and will go down. So while a turning point here, when there is no reflection, is actually the lowest point on the graph. In case if we have reflection, if we have minus here, then turning point will be the highest point on the graph. A is dilation factor, and that factor is actually telling us, or if you like, that factor changes this parabola on the way making it more closer to the y-axis or more open. In my paper you have a few different drawings for dilation. I will make them again here. Let's say if our graph is like this, and dilation factor for that graph is, let's say, 10. Then if dilation factor for this graph which is more open, is 1, or let's say for graph like this, dilation factor will be maybe just a half or even smaller. So as we can see, as this number higher, graph is closer to the y-axis, but if that number is a smaller number, then parabola is more open. So going on this way. It is very important, 3, in this case, H, and that is horizontal translation. Horizontal translation. This number, actually, translating this graph horizontally, or that way, or on this way. You have to memorize. If plus, for plus, then graph is going to the left. So if in this form we have plus, then this graph will go on this way for that many units as h is. And of course, if minus, then graph will go to the right. So if we have minus here, then this graph will go on that way. And finally, K is vertical translation. And that number telling us for how many units this graph going up or down. And if plus here, graph going up for k units, if minus, graph going down for k units. Those two, horizontal translation and vertical translation, are very important, and obviously as moving this graph somewhere else, horizontally or vertically, then those two numbers are actually coordinates of turning point. So we can write coordinates of turning point will be minus or plus h, but plus or minus k. Be careful here. Minus on the top, plus on the bottom. Here, plus on the bottom, minus, plus on the top, minus on the bottom. So it's like opposite. That means if you have here plus some number, and if you have to write coordinate of turning point, then coordinate here will be with minus. The number will be the same, of course, but the sign will be minus. While for k is the same, plus on the top, plus on the top, minus on the bottom, minus on the bottom. So for k, we are not going in a different direction. This is basically what we have to memorize to be able to sketch any parabola and to understand how to analyze a parabola. This definitely we have to memorize. We can't without this do much things. In some textbooks and in some schools, teachers are giving you a bit different approach to sketching parabola. They are not talking much about this form. They are not insisting to change this form to turning point form and to use turning point form to sketch the graph. Instead, they are simply giving you equation of line of symmetry of parabola, which is minus b on 2a, and that is actually coordinate of x coordinate of turning point, while b squared minus 4ac on 2a is on 4a, sorry, is y coordinate of turning point. I mean, it's okay, it's everything fine. You can use those two formulas to sketch your parabola, but here with me I would always go on this way. Why is that? Simply because you are not studying to sketch parabola now in this time, and you don't need it anymore at all. In fact, you are studying now to sketch parabola, to understand the concept of sketching parabola, that you will be able later on to apply it on any other question that you have. That is one reason. Another reason is because at the beginning I said that in year 11 and year 12 especially, you will be graphing too many different types of functions, and you will be using the same method, that is transformations of graphs. So this is actually starting point for transformations of graphs, and better to learn it right now. Later on, when you're moving on the other types of functions, you will have some idea about transformations of graphs, and it will make you easier to study other functions. Otherwise, using just formula to calculate coordinates of turning point and to guess if parabola like this or parabola like it's down, really it doesn't give you any advancing your knowledge for later chapters. And especially in year 12, you will be doing the whole year just transformations of graphs. I mean other chapters, but everything involves transformations of graphs. So please start thinking about graphing in this way. It will be beneficial in coming years. Okay. Now, what to do with all this knowledge? How to get graph? We have to have one logical steps that we have to follow to succeed, to successfully make our graph. So first thing, you have to check if your function, if your equation that you have to sketch is in turning point form or not. If not, then change it to turning point form by completing the square. Then, when you, in next step, when you have turning point form, always make sure that you are writing coordinates of turning point correctly. So apply this to that to write coordinates of turning point. When you have coordinates of turning point, then what you have to check? You have to check for reflection. So in your turning point form, here you will see if you have minus in front, then your parabola will be reflected like this. If it's plus, so parabola will be like that. At the moment, don't worry much about dilation factor, only take care in case if your task is to sketch two parabolas on the same set of axes, but with different dilation factor. In that case, you have to make some difference between them to be correct, of course, but those questions are very few you may have now. It will be in year 12, but at the moment I concentrate on reflection and on turning point. Of course, if your question is asking you to find x and y intercept, then of course you have to solve equation making y equals 0, and solving quadratic equation for x will give you x intercepts, while y intercepts, of course, if x equals 0 in this equation to get y intercept. Now we can sketch a few parabolas to see how we are applying all of this. I have some parabolas here. Also in this paper here there are about I think 10, 11 parabolas, and again when we are studying concept, when I am talking about concepts, examples that we are working are really critical examples. That means not repetition and very little difference. There are actually a bit bigger difference that we can see the full application of concept. Also, examples on this type of sessions when I am talking about concept are almost all possible situations that you may have in any question. So once again, those examples you should work on not to memorize, because it's very hard to memorize, but try on those examples to understand concepts and to see those differences and memorize actually those differences that will help you for later questions. I would suggest you for each of those questions to look in your textbooks or from your teacher material or whatever, for each of questions try to do similar, like let's say this question, another 2, 3, then for this another 2, 3, then for next question another 2, 3, and then definitely your concept will be in your head forever. Anyway, let's start sketching. First, I wrote this equation here, so why not to sketch it? Just let me, I will copy it here. Y equal x squared minus 3x plus 1. You don't have this example in this paper. Just I see it here and better to sketch it. So what? We can't sketch it because this is standard form, but we need turning point form. To get turning point form, we need to complete the perfect square. And completing the perfect square will be then x minus 3 divided by 2 power 2 minus 3 on 2 squared is 9 on 4 and plus 1, so y equal x minus 3 on 2 squared minus 5 on 4. And now we have turning point form. I will write under copy our turning point form plus or minus a x plus or minus h squared plus or minus k. Now we can compare this sign and that sign, this number and number in front of brackets. X is x, then h and that number, and k and that number here. So everything here is on right place like this, and then we can go on next step to write coordinates of turning point for our function. So coordinates of turning point then will be minus or plus, so opposite sign of minus. Here we have minus, but now will be plus 3 on 2. And for k, the same sign. Here we have minus 5 on 4 and minus 5 on 4. So we have coordinates of turning point. Next step will be to check for reflection, to see if this parabola reflected or not. Of course not, because it is plus here, and parabola will look like that. And the dilation factor, of course, is 1, so we said we shouldn't worry about the dilation factor. Without finding x and y intercepts, we can sketch just correct the shape of this parabola. So 3 on 2, that is about 1.5. Positive, let's say 1 is here, 1.5 will be somewhere here. That is x coordinate of turning point, and y coordinate is minus 5 on 4. This is 1 and 1/4, so somewhere here, and turning point of our parabola would be here. So now this point we translated today by horizontal and vertical translation. No reflection, so our parabola will go on that way. And of course, if we are looking for x and y intercept, we will get much more accurate parabola. Let's see just if it's y intercept at 1, so should be somewhere here because it's very quickly to see it. And our parabola, then I will use different color, will be somehow like this. And we've got a graph of that equation without big trouble. So all what we have to now to change it to turning point, then to write coordinates of turning point, and to check for reflection, and of course for accurate graph we have to find x and y intercept. Now we will continue with other examples. So we need to sketch graph of y equal x minus 1 squared and plus 2. We have to check if this graph is in turning point form or not. Yes, it is in turning point form because we can recognize it. And coordinates of our turning point for this graph -1, but here will be +1 and +2. And no reflection. So again, parabola like this. This point will be the lowest point on the graph, and 1 and 2 is turning point, and that point is the lowest point on the graph. So again, graph will go on that way, and obviously no x-intercepts. Here, something what you should try to practice to see actually some things without calculation. Suppose if they ask us to find x-intercepts, or for some reason we should see where x-intercepts are. Really, we shouldn't do anything. We shouldn't think even, because we can't continue this fully to factorize, to apply north factor law to find x, because plus here is not minus. And in that case, the discriminant of our quadratic trinomial here will be negative, so no solutions, no x-intercepts. And of course, we can see if turning point here and parabola going up, so we are not touching x-axis anyway. And yeah, graph is like that. Maybe we don't need this anymore. I will remove it. And of course we don't need this because we know this. Our next question is y equal to x plus 2 squared minus 3. What I said just a while ago about x-intercepts, again, straight away here when we look in this equation, we have to see this graph will have x-intercepts. How do we know? Because it's minus here and plus here, so those two terms are opposite in sign, and we can apply difference of two squares when we make y equals 0 to solve that equation to get solutions for x. But anyway, we will discuss it a bit later. So again, turning point will be -2, because here plus, then a coordinate will be -2 and -3. Parabola not reflected. We have dilation factor of 2. That means this number will narrow a bit our parabola, and that's all. So, sketching is -2, 1, -2, -3, 1, 2, -3, and turning point is somewhere here, and parabola going on that way. It will be very narrow, because y-intercept very easy to get when x equals 0. So 0 plus 2 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 3 is 5, and if this 3, 5 should be somewhere here, and we will have a graph like this. What we said at the beginning for basic parabola has a line of symmetry, and any other parabola has line of symmetry, and that line of symmetry is right through turning point. So what it means? That means this distance from here to there is the same from here to there. So this line is always on the middle, or somewhere else. Here, let's say that distance and that distance, they are the same. So that means a line of symmetry. Sometimes maybe we will see on later sessions when we do application questions. Maybe we will now just one x-intercept, and we will now coordinates of turning point. So we don't need to solve the equation to get another x-intercept. So we know that that much will be from this line on this way, and we can get x-intercept as right. Oops, sorry. Now, another question, y equal 4 minus x plus 1 squared. Okay, let's first see if this form in standard, turning point form or not. Looking like this, someone may say not like turning point form, some other may say yes. I mean, it's not exactly like written here, but the form is turning point, because doesn't matter if this fall here or on this way. So when you write 4 minus 9 or minus 9 plus 4, we have the same result. So if someone confused, then easy to change it anyway, and now we are just exactly the same. But as I said, it is not necessary, because how to look in forms, that is another problem that some students may have. When we talking about a vertical translation k here, what we can say, k is added or subtracted from this major part of our equation. And any number that is added or subtracted to that part, that will be vertical translation. On the other hand, dilation factor. Dilation factor is actually number that multiplies this perfect square here. So, if you have, let's say, here 4 first number to be first number here, then we can't say 4 is dilation factor. Why? Because 4 doesn't multiply this perfect square. 4 is actually added or subtracted to this, and that's why 4 is vertical translation. So when we compare our question with some forms, with some formula, we can look it really just like you are looking at some picture. You have to think mathematically. You have to see mathematical operations. You have to see mathematical operations, and actually to compare mathematical operations and parts of your equation, and then when you compare mathematical operation and parts between them, in that case you can state yes, it is in standard form, or no, it's not in standard form. Anyway, turning point coordinates. Horizontal translation for 1 unit to the left, it will be -1. Vertical translation 4 units up. and we have coordinates of turning point. Minus means we have a reflection. Parabola is down. And turning point will be the highest point on the graph. So minus 1 plus 4, and turning point is somewhere here, and we have a reflection, and parabola is like this. Again, if you like to calculate y-axis, y-intercept, it will be x0, so 1 minus 1 plus 4 will be 3. So parabola will be passing to point 3, and of course that much on the other side will intersect x-axis and reasonably graph for this equation, because I said we are not finding x and y intercepts in this. Y-intercept maybe occasionally, but not x-intercept, because it will involve. Yeah, okay, let's go. Here is its problem, because sometimes maybe you will need, and when we did factorizing, I said most of people at the moment when they do factorizing in school or with tutor or when they are practicing at home, they're like, okay, but now if you have to find minus x plus 1 squared plus 4, if you have to find the x-intercept, probably too many students will start thinking, okay, what to do? I will expand this and to get the equation like that, and then to try to solve the equation, maybe to use quadratic formula, and going somewhere until you make some mistake. If concept of factorizing is in your head, then it's quite obvious. If this 0 here, okay, I have two terms, but 1 minus 1 plus, so I can apply difference of two perfect squares. I can keep it like this, but also you can use this form here and to write 2 minus, be careful, x plus 1 multiply 2 plus x plus 1 equal to 0. Difference of two squares you are applying on this and getting this from here, just to calculate x. I mean, that is how mathematics is not just studying on sports. Now I'm studying this, I don't care anything about what I studied before. I need to understand that. You never will be able in mathematics to understand some topic if you are not calling your knowledge from earlier topics that you studied. And of course, whatever new you are studying, remember, you will need it for coming topics. So knowledge in mathematics is actually one continuous chain. We are just making up things one on each other, and that's how we understand mathematics. Otherwise, we can't study just this, forget, then I'm studying this, forget. In that case, you can't understand anything.